Okay, so this one's maybe even more of a challenge. You got to pull it a little bit back towards you guys. Okay, so maybe let's see how it goes. What's the first thing you want to count?
Let's count the faces.
Okay.
So I'll count the pentagons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 again.
Interesting.
And squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then there's going to be 10 more. Or 1, 2, 3, 4, 5, 1, 2, 3, 4, 5.
Is it on the bottom too?
What do you mean? I'm counting the squares.
Oh.
Okay, so how many squares were there?
So 5 plus 5, 10 plus 10, 20, 30.
30 squares, 12 pentagons, and now we got to count the triangles.
Well, there's 5 around the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And then 5. So there's 20.
Okay, so 12 pentagons,
30 squares.
30 squares.
10 or 20 triangles.
Okay.
So it's 62.
Wow, 62 faces. Okay.
How about edges?
Well, the edges. Is there any simple way you could calculate them?
Well, you can't just look at the pentagons.
Well, you can look at the. Can't you look at the pentagons and the triangles? Because you're excluding the triangles.
Yeah.
And that would count the squares too.
That would work. There wouldn't be any overlap.
Okay, so what was your plan?
Count the number of edges on the pentagons and the triangles.
Okay, why don't the squares matter?
Because you're counting them. When you count a pentagon, triangle, you get a square.
Ooh, cool. All right, so how many pentagons were there?
So I think there were 12.
All right.
12 of them. So that's 60.
60 edges.
Then plus triangles 20.
60, and then 20 times, there's 3 edges, 20 triangles.
So that's 120. Wouldn't it be?
Well, there's 20 triangles.
And times 3 edges.
Yeah, it's 60.
And then plus
60.
the other 60.
Yeah, so that should be 120.
Okay, so we had 62 faces. It looks like we have 120 edges.
So
How would
I'm
we count the vertices?
guessing there'd be 60 vertices.
60 vertices.
And they see a secret way to count them.
Because with the pentagons.
Yep, because the pentagons get all the vertices and they don't overlap.
Oh wow, so each vertex is in exactly one pentagon.
Yep.
So how many vertices are there?
So there's 60.
Cool. And does that work?
Yep, that works.
120. Sorry, 60 minus 120 plus 62 is 2.
Yep.
Now I'll show you while you guys are making something. Bring back the original icosahedron. Something's really cool about this shape. If you pretend all the edges are 1,
Yeah.
and you put a sphere around it, you circumscribed a sphere around it, the radius of that sphere is the golden ratio.
Cool.
Wow. So there's a surprise appearance of the golden ratio.
Yeah.
Yep.
All right, good work today, guys. Sorry about that snub cube. Sorry for misunderstanding that, but we tried hard to make the snub cube. All right, good work this morning, guys.